Hello, everyone. Good afternoon. Good evening. May I ask all of you to turn your video on, please? All right, thank you. All right, thank you very much. You know, if some of you turn your video off, and then some other kids would also like to turn off. If everybody turn it on, so everybody can see each other, I can click individual. Okay, ask you to start a video. All right. So this is our class number 9. We've been in the class more than 2 months, right? Right? Okay, everybody turn your video on and then we can get started. Thank you. All right. Um, let me share my screen. Can you see my screen now?
Yes, we can see
Okay, great, thank you. Yeah, all right. All right, as I said, this is our class number 9, and then we will have 21 classes for this B30. All right, so you are still going to learn a lot in the future. All right, let's look at the survey results first. Homework survey results. A little bit slow. Oh, I know where it go. It go to my other screen. Okay, let me put it out here. All right. See if I do that. All right. See how many responses is loading. Ooh, what's that? Oops. What's wrong? Okay, here we have 115. All right. I see the number going up, but not that significant. Let me see summary. Okay. Still Lucy and Mindy, Alex, James, and then William. For those other students, please, okay, get some time to do your homework. As I said, doing homework is very important. If you really have some issues or could not figure it out, and then you can post your question to the club and ask other kids. Definitely, there will have some student can help you, or you can just one-on-one talk where the Zoom, right? You don't need to directly go to club because we have more than 290 people there. You can just communicate one by one because you can see the list. You can just go to club, say, okay, I have a question. Could anybody help me? And then you guys can go to private chatting. All right. Uh, Otherwise, you know, your parents pay your tuition for this class and they really wanted you to learn something. And then at the class, you basically you kind of listen my story, but you probably will not have a lot of time to practice. Doing homework is very important. This is the only opportunity for you to exercise what you learn, right? In the class. This is very important. Very important. Otherwise, you will forget what you learn. Um, yeah, look at it. Okay, score and AOPS. So I see, okay, 10. All right, still the level 10, one submission. I didn't see, last time I saw is a level 10 for one submission, right? So I hope I see the number becomes greater. All right, and yeah, all right. So I hope you keep working on your homework. All right, so let's get started. All right, pull out my pen. Uh, surprisingly, see, okay, we start from graphing linear equation lines, and then we went through everything on the second column. Sorry, I didn't draw this line straight. And then see, we move to the third column for algebra B part. This is really the core part of that. And so last time we talked about the quadratic formula. I'm not sure when you do homework, have you tried to think about at least two way? One way is completing the square. Another way, you can directly use the universal quadratic formula, right? Also, the third way is that sometimes if you have easy problem, you can use a cross-factoring approach, but that's for easy problem. Quadratic formula will be the a universal one, okay? If it is a quadratic equation, you definitely can apply this formula to it. If you see the number under the radical, it is the negative number, then you have to have something come into your mind, which is the imaginary number. For imaginary number, you have to write in the format as a plus b I, okay? Remember, this is a standard format of complex number. You have to separate this I with the coefficient, and then you separate the real number. You use this format to express the complex number, right? So for this class, we are going to discuss something about graphing quadratic. Remember our first class, we talked about graphing lines. This is based on the linear equation, which is, for example, x plus 1 equals 0, right? But here we talk about the quadratic. It will like this, x plus 2x plus 1, x squared plus 2x plus 1 equals 0. So this is we call quadratic, right? And this is we call the linear equation. Quadratic equation, that's the difference. That's the reason why we call this x squared, we call quadratic term. We call 2x linear term. We call this one constant, okay? So basically for this graphing quadratic, there's a two part. One part is called parabolas. Parabolas. Second one is circles. For this class, we are going to talk the first one, and then we leave the circles for the next class, all right? I already review a little bit um, for the quadratic equation, but this is a very important one. We have to remember. I can tell you, if you memorize this, you learn this, definitely, as I said, for SAT test or some other math test, they definitely you will see this type of math problem, which will use this quadratic formula. It is very, very important, right? You have to remember this. Especially you have to remember this discriminant, okay? It's very important. As I said, how to memorize this? here the b squared is kind of like b times b minus 4ac, right? So this is power of 2 looks like, right? This is power of 2. If you think about if a equals c, this one will becomes 4a squared, right? They all like b squared minus 4. This is squared. And then you have radical here, square root here. And then the final result will be power of 1, right? That will be same as this, power of 1, right? So here on the bottom numerator is a, okay, term of a. Here's b. So now you have to remember this minus. So that will be very easy for you to memorize this. Okay. Again, so this will be the standard form for quadratic. As I said, this is the quadratic term, linear term, constant. For whatever a problem with a quadratic equation which has a different format, which is not a standard format, right? You have to turn this into turn it into the standard format. Like if you see something like ax squared plus bx equals minus c, okay? You have to move this to here. Otherwise, you easily to make mistake. You have to write as this format. This is called standard format, right? On your right side, you keep it as a 0. Only in this situation, you can easily figure out what is A is, what B is, and what C is. And then you plug in here. A, B, and C, okay? This is very important. All right. So, I mentioned that the discriminant, we call this b squared minus 4ac. There's actually 3 situations for b squared minus 4ac. Either this value greater than 0, equal to 0, or less than 0, right? For different situation, you probably get different type of problem. Really depends on situation. For example, if this discriminant greater than 0, right? That's really give you an regular results. It will be 2a minus b plus minus. You have plus minus. That means you have 2 results. You have 2 results because here is greater than 0, right? What about if this b squared minus 4ac equals 0? And then you only have 1 result, right? You only have 1 result. Which is minus b divided by a, and divided by 2a, because this discriminant equals 0, okay? For the third situation, if this is discriminant less than 0, so a number under the radical less than 0 is definitely, you have to think about, that's not the real number. That is an imaginary number. So you simply factor -1, square root -1 out, and then you can label it as I. And then you can easily turn this negative discriminant into imaginary number, okay? As I said, for example, you have discriminant equals -2, okay? And here you can easily factor out like this situation, right? Because you all learn that you can factor -1 out, and then this is a real number. This is not real number. This is equals I. And then you can easily to write it as square root 2 and times I, okay? Keep this in mind. Like I said, for last chapter, if you can remember this quadratic formula, and then I think you probably get at least 80%. All right, it's pretty easy. As I said, pretty easy. Just one universal formula you need to memorize. The easiest way for you not just, mentally memorize it, you can use another way. You just write it down on your paper for 10 times. You definitely will remember that. All right. Yeah, trust me. You write it down on the paper 10 times. Okay. Um, okay. Then another thing is, um, it says if the quadratic with real coefficient has root, okay, we call the results roots are not real. That's an imaginary number. Then the roots are complex conjugate, of course. If you have one, you have result 1 plus minus this, right? This is your final result of roots. So definitely they are the complex conjugate to each other. 1 plus square root 2 times I is the conjugate of 1 minus square root 2 of times I, okay? They are conjugate. So another one is, sometimes, you may see the problem is asking you something about the sum of roots, the product of two roots. Um, if in that situation, you have no any other idea to do it or a simple idea to do it, you can try this because you definitely can have two roots. One is plus, another one is minus. And then you just simply add them together, you will get the sum of them. And then you will realize these two discriminant terms can be cancelled if you add them together, right? Because here's plus, here's minus. They can cancel if you add them together, right? What about if you times them together? If you times them together, you can still simplify it. What you can simplify? Why? Because if you still remember the difference of square, right? You have a plus b times a minus b. What is equals to?
A squared plus B squared.
Yes, this is called difference of square. You
And
definitely, yeah.
yeah, and
Yeah.
like the minus B is the A, and then the discriminant is B.
Yes, exactly. Just thinking about, you have to think about what you learn and try to associate them together. Then, like I said, if you learn with me, I'm trying to help you to turn this big book into a paper and then becomes everything just in your mind, right? It's gone, physically gone, but you keep everything in your mind. That's the thing. How do you learn that? You have to associate this everything you learn with what you learn in the future, right? You keep in mind what you learn, right? This is what you learn. You have to think about associate them together, all right? Okay, keep it in mind. So let's do a quick preview problem. Yeah, please write down this question and then have a quick thought. If you look at this question, looks like, you know, if you first time see this type of question, probably you really do not have any idea. You really do not have any idea what it is, what is testing you, right? But as I said, don't worry about it. If you do not have any idea at the beginning, it doesn't mean you do not have any idea in the middle of the calculation. You at least start with something and then you do it, and then in the middle of the process you probably realize, aha, I will have some idea to solve this problem. Here, it asks you this, okay, this doesn't mean anything. You have no idea. And what's the points of and the points of this lies on the graph of this. Wow, it's showing the words graph. Do I really need to graph something to figure it out? Oh, I can absolutely just based on this expression or equation to do that. So you may have no any clue. And then what is asking what a B is. What is really asking you, right? Think about it. How do you do that, right? Okay, keep thinking it, and then you can bring this question with you, and then we can start our topic. All right? Yeah, you just hold it in your mind. Okay, later on you can talk about that. I heard that somebody wanna talk about it. That's okay. Good, good. I think you already probably have some strategy. Let's move forward. Chapter 14. Okay, we start a new chapter, right? Graphing quadratics, because we learn a lot of quadratic, as I said in the previous classes. We start with the quadratic expression, then we learn some quadratic equation. We learn some skills about factoring. Last time we learned we learned some factoring. So on previously we learned some linear equation. So and then now um, let's see how we can graph a quadratic. All right. So we are going to talk the first one, parabolas. Okay. Problem 14.1. Graph the equation y equals x squared by first plotting several points that satisfy the equation to figure out what the graph looks like. Yeah, you know, learning parabolas is always, people always start from this simple quadratic equation because here it only contains one term, which is quadratic term. But later on, you are going to learn the complicated form x squared plus 2x plus 1, right? You will have three terms. But now let's start from the simplest one with only quadratic term, right? Um, let's look at it first. So this is like a traditional way when when we were doing a linear equation. Um, but for linear equation, it's kind of only one variable, but here you have two variable. You have x. Let's start from 0. x0 and y0. X minus 1, you got y equals 1. Why? Because you have squared. If x squared, and you will get a positive. And negative 2, got 4. But on the other side, you have 1, 2, 3, and then you got the same answer, 1 and 1, 4 and 4, and 9, 9. Of course, right? Because we all know that this is square. This square played a role to convert all the results of y into positive number, right? So what kind of graph you can plot? Of course it will be like this because we know, as I said, the square convert all the y results into positive number or 0. If x equals 0, it will be 0. And then x equals 1, y will be 1. 2, o becomes 4, y becomes 4. Here, this coordinate will be 2 and 4, right? And then you know this will be minus 2 and 4, right? So, and then looks like, the point are symmetric, right? They are symmetric. And I can tell you, this is really the standard graph of y equals x squared, right? So we call this shape of graph is parabola, right? So the line that is the mirror is called axis of symmetry, right? Because this is kind of like a mirror in the um yeah mirror is y-axis, right? So what's the intersect point? Intersect point is here because if you look at this is the tip of this shape of this graph. All people call this is a turning point because if you going this way, going this way, going down, and okay, it's turning point and going up, right? We call this a turning point or the lowest point on the graph. We call it vertex, okay? So now you learn these three terminology, right? Parabola, axis of symmetry, and vertex. Okay, keep this in mind. You have pencil and then paper, write it down, and then which can help you to memorize this term, right? So, in the future, I'm going to keep talking about these terms. Yeah, of course, x coordinates are positives and the y coordinates are the same, right? Each pair, because they comes as a pair. One, as I said, the 1, 1 and minus 1, 1. This is one pair and this is another pair, right? That's the reason why we call they are symmetric. Give you a few seconds to read it again and then try to memorize it. I don't want to go too fast because this is a new things to you. Any question? Okay. If you have any question, okay, feel free to raise your hand. Just yeah, just there's an icon, right, called reaction, right? Reaction, and then you just raise your hand. Yeah. Um, yeah. So okay, problem 14.2. Graph the equation this, and this. Wow. They look similar, but they are really different, right? What's the difference between them? Do you think their graph will be same or different? Right? You have to think about that in your mind. They all have the same x squared, and x squared, but the coefficient are different. This is 5. This is 1/5. Okay, 1/5. This is minus 1/5. Okay, minus 1/5. 1/5. Okay, 5. Of course, they are different, but if you plug in an x, for example, 1, you definitely will get a different value of y, right? That's for sure, right?
Yeah.
So, yeah, okay. And then let's look at, okay, because you guys just started learning, I don't want you start graphing that, and I just show you some example. Um, like in the previous slides, if you still remember, we plot the y equals x squared, right? You doing like this, right? You have x, let me write down here. Because you have 1 and 1, and then you have 2 and 4, okay? And then you have 1 and 1, 2, 1, 2, 3, 4 here, right? So now we can plot. Sorry, my smart pen is not too sensitive. I cannot use it very good. So this is line is not very smooth. Okay, so if we have y equals x squared, we will have this right line. And then if we have y equals 5 times x squared, and then you see this curve looks like this. Looks like this. Why? Why? You can write this as x squared times 5, right? Why? Because you get the same x, for example, is 1. Here, you increase y value 5 times. You make this curve, or you make this graph sharper, going up. Okay, sharply going up, right? That's the reason why if you have x squared times 5, you make this curve going up quicker than x squared. What about situation if you have y equals x squared times 1/5? Or you can write as x squared divided by 5. Looks like you decrease your y, right? What are you gonna get? You are going to get this. Get it like this, right? Why? Because you decrease the y value after you apply this coefficient. You apply 1/5 or you divide by 5. Alright? So looks like you change this coefficient and then you change the shape of curve y. Right? Okay. Then exactly let's look at this. If you change the coefficient from 5 to 1/5, you make this curve shallower, not sharper, going up, right? And then another thing is, if you add a negative sign, and then looks like you change the direction of this opening. Previously is opening to the up, it's opening up, but now it's opening down. Why? Because now just you times 5 or 1/5, you also times a -1, right? You times a -1, and then you turn all the value of y to negative number. That's the reason why the opening down, okay? The opening down, right? So now what you see is two changes. One is the curve can becomes sharply going up or shallowly this one going up, or the opening going down. For opening down, it could be like this, or it could be like this. Let me ask you, what you can get if I plot a curve like this, graph like this? What has been changed for coefficient? Could anybody answer my question? The opening down. And then it's close to y. Okay. Let me tell you. If opening down, the coefficient definitely will be minus. Okay. Right? You know this, right? And then if close to y, it has to be greater than 1. Coefficient greater than 1 added. Right? Because this will increase the absolute value of y. Is increased 2 times. So this minus sign changed the opening direction. This number or this value change the shape of the curve. Okay. I think I slow enough, and I hope you can understand. But now, this is a Cartesian plane, XY plane. As I said, again, you have this standard. You always think this will be a good starting point. Y equals x squared. Like I said, if you change the coefficient, if this is coefficient greater than 1, it becomes sharply going up close to y because you increase y value. You increase y value 5 times. For this one, you decrease y value 5 times and then becomes cellular, right? Becomes this, right? Clear, right? So the summary is the coefficient of quadratic term is not the only term that affects the graph of that is not the only term affects the graph of the quadratic. There's definitely something else, and then let me talk that later, right? And also, as I said, minus sign can also change the opening. Okay, minus sign change opening. Quadratic term change the shape. And then also there's some other terms can also change. Let's continue. Okay. So now, if a quadratic is written in form of this, what is the effect of changing h? Wow. So it's kind of a big jump, right? What we just learned was y equals x squared ax plus bx plus um, um, c or something, right? We kind of we're using the standard quadratic format, but now it's kind of like let us doing this. I can tell you, this is another way to express quadratic because this is standard form of quadratic expression, but this is the binomial square way of for the quadratic, right? So especially when we talk about the graphing quadratic, we are going to use this format. I think this is also something you need to memorize for this class as well. I'm going to explain more of this, and then you definitely will easily memorize this at the end of class. Okay. Um, so let's look at several graphs. Um, you do not need to memorize now, but later on, you will not forget, and you definitely will memorize it. So let's look at it first. We know, we have. Oh, sorry, I could not draw clearly here, right? We know we have y equals x squared, right? And then we have vertex 0, 0, right? So, however, for here, what you see is x plus 3 and then also plus 3. Basically, you kind of change a little bit for this because here is only x. You can write this as x plus 3, right? Square. You use x plus 3 to replace this x. And then here is basically 0. And you turn 0 to 3. Now, you have this equation. And interestingly, you see what this vertex is. This vertex is 3 and this minus 3 and this 3, right? You may realize this is minus 3 and 3. Is that something related to this and this? I can tell you yes. That's the reason why we write the equation in this format. This format will help you to identify vertex easily. Okay. This will help you to identify vertex easily. But I think I would like to write this one as this format. X minus minus 3. You know this minus minus equals plus, right? So now, sorry, 3. Now you have this number, you have this number. Maybe you already realize this and this, right? So if you write in this format, this can represent the vertex, okay? Represent vertex. Then let's look at another example here, exactly. X minus 2, and then squared plus 3. And then let's look at what his vertex is. Is 2 and 3, right? This is vertex, right? So, and then for this, what is vertex point? Is 5 and 3, right? Similarly, for this, minus 3 and 3. Oh, yeah, they are same, right? Yeah, they are same. And what about this? This is minus 3 and minus 2, right? And this is, could anybody tell me what this? Mindy, do you know what the vertex is for this?
Minus 3, minus 5.
Okay, minus 3 and then minus 5, yes. Because, you know, if you can read it from graph, what about, you know, let me write an equation directly. Can you still figure it out? What is a vertex? Could anybody tell me? Just based on this equation.
2
Because
and
as
1.
yes, it'll be 2 and 1. That's the reason why, as I said, for quadratic graphing, we prefer to write the equation in this way because this format can directly tell you what vertex is. If you know vertex is, and then you will easily to graph the quadratic. Okay, clear? I think it's very simple concept. Because we use 6 example here, let's come back. This is really a universal format, right? We use y equals a times x minus h squared plus k. Okay, it looks like very hard to memorize, but let me tell you a little bit details, okay? You know, we have the first example, simple example, y equals x squared, right? Here, because this vertex keep moving around from 0, right? From 0, 0, here 0, 0, right? So for y equals x squared, it looks like here. This vertex point keep moving around. In other words, let me ask you. Let me see. Oops. Where's my pen? Okay. What's the vertex of y equals x squared? Could anybody tell me?
0, 0.
Yes, because you can write this as x plus 0 squared and plus 0. Right? So you have vertex 0, 0. And then if I change it to y equals x plus, here we'll say h and plus k, what this vertex will be. Sorry, here square.
Minus HK.
Yeah, looks like you. Okay, you get everything. Good job. This will be minus h, and then k. But why? Why here's plus, here's minus? Could you tell me?
Because in the equation it says AX minus H, and then in parentheses squared plus K.
Yes, you are right. You are right. Yeah, but you just remember here, I can tell you why a little bit later, right? So now, that's the reason why we would like to write as, well, here technically is x plus 0 or minus 0, and you get square. Let me clear it up. Okay. All right. So as I said, sometimes using simple example, you can write as, at this time I will write it minus 0, okay, plus 0 square, right? X minus 0 square plus 0. Now you convert it to a universal formula. You put it h here. You put k here. You add a coefficient a here, right? Right. So this represents the vertex. Okay, represent vertex of x. K represents the vertex of y. H represents vertex of x. H represents vertex of x. Keep this in mind. Let me see if the next slide I definitely will have a better example to show you. Okay, this is the formula or equation we just had, right? As I said, H is the vertex of x. Okay, changing H moves the parabola horizontally. That's the reason why it's used H. Okay, that's the reason why it's used letter H to represent that. For example, here you have xy plane. If you have y equals x squared, you have vertex 0, 0. And then now you want to move the vertex to here, for example. I will use h and k to represent this vertex, right? And then you can plot. Oh, you can plot. Okay? This here, h and k, just represents the moves of 0, 0. Okay? The x towards x direction and the y direction. Any question? I really want to slow down and then ask you if you have any question. This is vertex, okay? So now, if I turn this equation into this way, I can help you to understand a little bit. Okay. Oops. That's not right. Okay. So if you move this k to the left side, it becomes y minus k. And this is x minus h. So now you will know why if I move the vertex H and K to here, and then it becomes this is all both minus and minus. If you still could not understand that, let me give you an example. For binomial product, for example, x minus 1 times x minus 2 equals 0. How do you quickly figure out what is x and what is y? I'm sorry, let's do y, okay. Instead of doing x, let's do y. How do you quickly figure out what is x equal and y equals? Could anybody tell me? For this equation, Jaden, what is x and y?
X is 1 and y is 2.
Yes, x is 1, y is 2. Here you have minus sign, right? But why? Because you can write it x minus 1 equals 0, y minus 2 equals 0. And then you move this one to here and it becomes 1. You move this one to the right side, it becomes 2. And you get 1 equals 1, x equals 1, y equals 2, right? So that's the reason why you have minus sign here. Similarly, here, you have to keep minus sign here, right? Okay, so now, like I said previously, if I give you this equation like this, a times x plus h prime, I will use h prime. H prime will be different from h, okay? Minus k prime. What is a vertex?
Minus h prime
And
minus k prime.
yes. How did you figure it out?
You just put in, like, you always have to multiply the h by -1, and then the k stays the same.
Exactly. Okay, that's kind of a rule. If you really cannot, figure out this way, you just, memorize the rule. Who said that? Who said that? Who told that one?
Ethan.
Ethan. Okay, thank you. So, Ethan just tells you the way or the rule you have to memorize. Okay, this one is definitely will be your y coordinate of the vertex. Okay, this one you have to yeah, for this situation you have to times minus 1 because this is plus. If you see this minus, there will be h. Okay, for this situation it will be h and a k, h and a k, right? For this situation, because this is plus, you have to convert it into minus h, all right? So that's the reason why you have minus h as the vertex. And then you keep using this one as the y coordinate. Okay, don't worry. Okay, well, I'm going to repeat it again and again. So I know once you learn, and later I will summarize it, and you think it's very easy. Okay. Again, I repeat it. H. Okay. Here's a minus sign. H representing the moves, the parabola horizontally, changing K to move vertically. Okay, I don't know. So why people don't use a V? Okay, a V probably is representing V vertical, but it's use K. But anyway, but as long as you know, H represent horizontal. Okay, and then K represents vertical. Okay, so changing H and K does not affect the direction or the width of the parabola. Okay, it's only change the vertex. H and K change the vertex. Change the vertex, not the direction or width, just shape. So again, for a parabola, it has a shape, like, right? It's just sharply going up or slowly going up. This is we call the shape or width. The direction means the opening, down or up. Okay, so H and K change because here we have vertex 0 and 0. H and K will change vertex to somewhere else, like this, like here. Clear? This is the only ways you can plot quadratic. There's probably no way you can plot a quadratic like this, okay? No way. At least, now is not time for you to do this. You cannot do this, okay? It has to be this way or the other way I'm going to show you later. X and Y flipped, okay? Yeah, it said H and K change the location, but not the direction or width. It's change the location. Now, direction, width, and the location. Okay, clear. Maybe I can ask you, Sam, do you have any idea what can change the direction of the quadratic graph? Direction, opening up and down.
Whether it's negative or positive.
Exactly. Alex, what can change the width of the parabola? Can you turn your mic a little bit louder? I cannot hear you.
It's at
Now it's
max
better. Now
now.
it's better. Yeah.
Okay.
What can change or change the width?
Changing the width is A.
Yeah, it is a coefficient. What changed the location of a parabola? Jaden?
H and K.
Exactly. Okay. Good job. Okay, I'm really happy about that. I spent okay, wow, almost an hour. Okay, good. Okay, you all understand now. Oh my gosh, I just afraid that it's not clear enough. All right. So this equation definitely will be your take home things. Okay, you have to memorize this. If you know this, okay, and then you 100% understand what I'm going to talk about this. So term of A is called coefficient. Term of H and K is something related to the vertex, okay? Right? And then the minus sign or plus sign determines the direction, okay? Clear? Just several things. For this type of thing, to quickly identify the shape, the direction, down, up and down, the vertex, you have to convert quadratic into this standard form, right? A will not equal 0, okay? I think that's all you need to learn, okay? I don't want to repeat, there's a lot of words, otherwise it will confuse you. Now you are good. Let's move forward. Okay, let's graph this equation. Like I said, this is a standard form of quadratic equation, but it is not standard form for graphing a quadratic. what you can do is you convert it to the standard form I just showed you. How do you do that? Could anybody tell me? It's definitely something you learned from last class or from previous 2 class. How do you convert it into y equals something a x minus something? We use h square plus k. How do you convert this one into binomial square? What do we learn? Completing square, right? Completing square. How do you do that? If you want to do this completing square, what you can do?
Basically, you take the -7, and then you take half of it.
Yeah.
And then you take that half, and then you square it.
Yes, you you take half of b, like this is b term, half of b, and then you square it, right? You square it. Okay, this we called. If you don't remember, you have to go back to take a look at the previous slides or replay my class video, or you just read the book. Okay, let's use this way. The book used very like the other way, but I directly linked it to completing square way to do that. Okay, if you want to write the form of this, you definitely need to do is here. You have this. You want to add a c term, which is half of b term, or half of b square, and then you get these 3 terms together. You can write it down as this square. It's called perfect square, right? Like I said here. Remember, this is half of b here. And what you need to do is also that you need to, yeah, because you add here this on the right side, you also need to add that on the left side. You still keep the 6 here because 6 is from original seat, the last term here. Now, you just simplify it, combine everything, the constant, you will get this. But now, you turn the equation into this standard form. So, tell me, what is the vertex?
The vertex would be 7/2 and -25/4.
Yes, correct. Because we know this is minus. Keep in mind, this is minus. If this is minus, you can directly read 7/2, okay? Because h represents the x coordinate of the vertex. Okay, you have h and the k as vertex, right? So, and k equals this. H equals 7/2, right? So, what is A? What is A? A is here. Obviously, A is 1. What about this, for example? If I got the answer is 2y of this, what is A will be? Could
Can you
anyone?
repeat that?
If here I write it as 2y equals blah 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 like this, what is A will be? Followed by following this. What is A will be? Alex,
Let me think.
if I write this as 2, what is
2.
A will be? If I write it 2y equals this, and then by following this formula, what A will be?
A will equal. Let me think.
Would A be 1/2?
Yes, obviously. Obviously, A will be 1/2. You move this one to here. It becomes reciprocal, 1/2. Do you think H will be changed? For example, I write it as 2y x minus. So we know A equals 1/2. What is H? Could anybody tell me?
H is 7/2.
Correct. Keep saying. Is K changed?
No.
Mm-mm. The K changed or not?
Yeah.
Yes. What is K will be? Okay. You guys all know that if you want to turn this coefficient into 1, you have to divide it by 2 on both sides, right?
Yeah.
What K will be? 25 over 8. Clear? Anybody have any question? Why? Why is 8? Because you here you have
Because
20. Yeah, it's minus,
it's
sorry.
reciprocal.
Yeah, because you know here you divide by 2 on both sides, and then what's this term? This term becomes minus 25 over 4 divided by 2. It becomes minus 25 over 8, right? Of course, this is a mental math you have to know, right? Okay, I think we did enough of that. So I think today we probably will not have time to take break. Is it okay with you? Or you want a 2 minutes break?
It's okay.
Okay. All right. So now, so by looking at this, quadratic, you cannot plot. It's hard for you to plot this graph unless you plug in x 1, 2, 3, 4, 7. You have multiple number and then you plot it. That's really time consuming. It's hard for you. If you convert into this equation, if you convert to this standard equation, you know the vertex is 7/2. You'll find here 7/2, and y is minus 25/4, right? And then you know the lowest point is, because you definitely know here's a plus. The opening will be going up, okay? And then you have some idea, okay, lowest point here, opening up. And how do you draw this curve, right? And then you probably think about, okay, definitely some intersect point on x-axis. That means if y equals 0, x could be 2 answers, right? So for example, you can go back here, y equals 0, you get x squared minus 7x plus 6, right? You will get 2 answers. You all know the cross factoring, right? Let me see if you
Yeah.
have 1, 1, and 1, 6. Can we do that or not? Yes, we can do that, right? So if you get minus 1, minus 6, you will get answer is x equals 1, x equals 6. So you have 2 answers, 1 and 6. So this becomes 1, 0. This will be the 6, 0. Right now you have 3 points. At least, you know, you have some idea. You plot this. It doesn't mean you can just plot a very accurate graph, but at least you know its shape looks like this. So that means this format help you to determine a ballpark shape of this parabola. Okay. All right, I have to move forward. What if the coefficient x squared is not 1? I think we already talked about a little bit. Let's look at it proper. For this situation, the equation equals minus 3. Wow. Minus 3. Previously, we only have plus 1 square. But now it's minus 3. What we can do? Anybody can tell me any idea what you can tell from this? Or
Maybe you can factor out -3.
yes, you can factor out minus 3 first, of course. Yeah. And you can, okay, let's do that. Minus, it'll be plus 4x. It becomes a plus, right? We can do that, right? Yeah. So, of course, you can do that. But here's the thing. Our goal is to convert this one into standard format, right? We probably still need to do convert it into binomial square, like what we did. Of course, one way that, yeah, so like here, you you divide it by -3, and then on the left side becomes this, and then you remove this, and then you convert it into this, right? The next step is you want to convert, like I said, you only focus on first 2 terms, quadratic term and the linear term. And then you're trying to figure out the this binomial, which is x plus half b, half b, half b. Okay, I repeat 3 times. I repeat many times. Half b, we call this one half b and then square, right? Because you add half b of this, actually you get 3 terms, right? You got an additional term of 4. So that means on your left side, you need to add 4 here. And then you keep writing down 5/3, 5/3. So basically you will get an equation like this. This one equals this, right? And then you further simplify it. You move this +4 to the right side because -4. And then you can calculate, and then you can simplify in this format. Now, you have this. But still, like I said, you want to get a y, you want to isolate y, and then you have to return this back. Or just like Ethan said, if you don't want to divide it by 3, and then you can just do that with this minus 3. And then you just do the computing square process following this one. You keep having minus 3 on this one. This is also fine. I just want to let you know. If you divide it by minus 3, you have to return it back. You can get y, okay, y equals minus 3, x plus 2 squared plus 7. Okay. Now, you convert this form into this form. Okay. And then tell me what's the vertex? If you want to draw a curve of this quadratic, what are you going to start with?
-2 and 7.
Yes. Okay, correct. Thank you. All right, -2 and 7. Yeah, like I said, if here's a plus, okay, you always has to write as a minus something, minus 2. So your vertical will be -2 and 7, right? So what is direction of opening?
Down because
Yeah.
it's negative.
Yes, yes. It's going down, right? Okay. And what's the shape, the width of this will be? Is wider or narrower than the regular?
I think it would be narrower.
Yes. Okay, here we go. This is a vertex -2 and 7. It's narrower because you have 3, coefficient 3. And then this makes the y value increase. I would say absolute value of y increase faster than regular. And it's opening down. Okay, here we go. All right, good. I'm really happy about that. You got that. Standard form again, and again. All right, I'm not going to repeat it. All right, what if y is squared instead of x? What I mean? So previously we talked about y equals x squared plus 2x plus 1 something, right? But now we flip the x and y, you know, x equals y squared. Oh, wow. What we can do? What we can do? I can tell you, it's easy. It's very easy. It's kind of like just changing a boy to a girl. Okay.
It's like the same. You just do the same.
Exactly.
Yeah,
You know,
it's just with the y instead
yeah.
of the x.
Exactly. You know, you have XY plane here is X and Y, but now you kind of like a plot is a Y is a X. It's just like a turn 90 degree or something. Let me know what the shape will be. What kind of shape will be? Just use your imagination. Because here you will get this. What's this? What's this way? So here will be Y equals X squared, and here if sorry, don't do that. So if we have x equals y squared, what will be on here?
Will it be?
Mhm.
I don't know if it's true, but will it be sideways?
Yes, sideways will be like this. So what about the vertex? Vertex will be same.
What do you mean vertex will be same?
For this one, vertex will be 0 and 0. What about
Yeah.
this vertex?
It's 0, 0.
Yes, 0, 0. It don't change. It won't change. It's the same thing. All right. Okay, let's look at it. Just as I said, you just consider x as y and y is x, right? You do the same thing, follow the same rule. It's just change a little bit. So this is the way why in your test, you know, sometimes for your this test and next test, they are the problem are different, but they are testing you the same concept. Okay, so similarly, you doing this, trying to do applying completing square way. You use y plus half of b, okay, half of this b. You got this. So if you expand this, you will get this, and then basically you add additional 9 here, and then you need to compensate on the left side is 9. So it becomes 2x plus 9 equals this. Okay, and then you further isolate x, and then you will get this. But now tell me, what is a vertex?
Minus
vert-
3 and
minus 7/2.
Yeah, okay, yeah, here we go. So let me clear up this one a little bit. Okay, yeah, here we go. So you're right. So, and you see this is a x equals something y square. And then the opening will go to your right direction. Go to your right direction. Let me ask you, what situation is go to the left direction?
When the coefficient is like negative.
Yes, yes. If it is a negative, it will go to left direction. Here, if I just simply add minus sign here, how do I plot this curve? How do I plot this curve? Tell me. Do you think a vertex will be changed?
Oh no.
Vertex will not change. So we can start from here, right? And then the direction will be left. What about the width? Width of this change or not?
Same.
No, right? So you basically this is what you will plot like this. Okay, they are symmetric. Okay, they are symmetric, right? So this will be their mirror line. Okay, okay, it will be like this way. Okay, understand? You simply add a minus. You will change that, right? Okay. So here, when you have this equation, okay, I think this is repeat standard form, and vertex is h and k, right? Make sure you know this. Okay. All right. So parabola opens to the right if a greater than 0, and then to the left if a less than 0. Right? Okay. So again, and again. So we only have 6 minutes. Let me see how many slides. Okay. We have a couple more slides. Okay. Now I think you know the basic concept. You definitely can easily to figure out this. A parabola has a vertex 4 minus 3 and a horizontal axis of symmetry. What I mean? What this can tells you?
Y.
that it's x, that it's x that's squared and not
Yeah,
y.
yeah. Why? Yeah, something like that, right? No, it's a horizontal axis of symmetry. Is kind of like this is y, this is x. It could be this way, right? Or the other way. All right. Okay. And it passed through the point this. So that means this x and y will be one solution of the equation. So it asks you to find the equation whose graph is this a parabola. Tell me your strategy. Give you 10 seconds. 10 seconds. What's your strategy? I can tell you, it's not
if-
okay, go ahead, go ahead.
So if the vertex is 4 and minus 3, we know that k is equal to minus 3, and then 4, and then sorry,
Negative 4.
h is equal to minus 3 and k is equal to minus 4.
Yeah, yeah. So this is a horizontal, this is a 4, k is minus 3, right? Yeah, right? Oh, but one thing I forgot to mention, let's go back. Sorry about that, I forgot that. Here, this is a difference a little bit. Yeah, I need to mention that. Okay, so the first one we learned was y equals ax minus h squared plus k. All right, so here's h. H means a horizontal move. This is a vertical move. And then x and h always come together, right? Here is turned to y. You have turned this into k. Again, k and y comes together. You turn this to k. H means a horizontal. H and x together. This h can move to here, becomes x minus h, right? This is different, all right? Be careful, be careful, be careful. Okay, I forgot to mention this. Be careful, all right? X go with h, y go with k. Yeah, y go with k. Okay, yeah. But now, because it tells us this parabola has a horizontal axis of symmetry. It will be like this shape of curve. And then you can write up this formula right away. X equals a, y minus k, and then squared and plus h, right? Now, and then you plug in this h, this is k. You plug in k here, and you plug in h here, right? And then you will get this. Alright, so it also gives you another condition, like I said. This parabola also goes through 5 and minus 6. Of course, you just plug in 5 and minus 6 to the equation of this. And then, see, everything removed except a. Right now, you can solve a. This is a linear equation. You solve a. A is 1 over 9. If you got a, okay, you know this is a. You know what k and h is, right? And you plug in. So this is the equation. Here we go. Here we go. So the point for this is you kind of know 2 points. One is vertex, another one is a point which this parabola pass through. You know 2 points. You plug in these 2 points into this equation or formula. But it's based on that you have to write up this equation correctly based on this language, okay? Based on horizontal axis of symmetry. You cannot use the other format. You have to use this format, and then you plug in. Clear? find the right formula of this based on horizontal axis of symmetry, and then you plug in this 2 point. Okay, yeah. Okay, we kind of over time, but I think it's very important. I really wanna let's see number 13, 16. How many more we have? Think about it, okay? All right, so we do not have too much. 16. I don't want to talk too much to confuse you, and let's skip this one. You definitely can look at slides by yourself. Let's revisit the quick review problem together. Actually, this is easy. It's much easier than what you thought. Or even it's easier than what we just practiced together. If this and this, you just blah blah blah, and then because you have no idea what it says, all right? Just skip it. This is kind of like just condition. Maybe later on you're gonna use it, right? But keep in mind there's a condition you will use, and the points, 2 points lie on the graph of this. Then what is B? Just like the previous example I just taught, you already know this quadratic equation. You know 2 point, right? I mean, you just think about what about you directly plug in this, what you can get. You may not need to convert it to like a y equals 8x minus h plus k, right? You may not need that. You may or may not need that, I said, right? But you can try this way, directly plug in. Exactly if you doing substituting the 2 point, you will get this. Interesting because here's a x1, 1 is becomes a, is b, and c, and y equals y1. You got this and you got this. Here, it's asking what is b is. What is b is you cannot eliminate b, right? You cannot just add these two equations together, and then you will eliminate b, and then you kind of like miss the point. You wanna keep the b, and then what you can do is you can eliminate a and c. If you wanna eliminate a and c, what you can do? Could anybody tell me? This is solving the system equation. If you wanna eliminate, even keep b and eliminate a and c, what you can do?
Factor them out.
What's that? I'm sorry.
Factor them out.
Factor them out? No. How do you do factor?
You can cancel them out.
Yeah, you cancel them. How to cancel them?
You
You
subtract.
need to add like you need to multiply 1 by -1.
Yeah. Or we can call subtraction. You doing subtraction, okay? You use the equation 1 to subtract equation 2. y1 minus y2, and then the top one minus bottom one on the right side, and it equals 2b. Okay? Okay, so you got 2b. So, because we know, now, keep in mind, there is a condition we haven't used yet. y1 minus y2 equals -6. We know that. And then what's b will be? What
B
b
equals
will...
-3.
Yes. Yes, of course, because 2b equals -6, and then b equals -3. All right. Easy, right? Think about it again. You have equation here. You know 2 points. Because we know for the quadratic, we can always plot like a parabola, right? And then there is a, let me see, let me plot this way, okay? They generally have two solution or something. If you know, all you know 2 point, any point here, you plug in, and then you will get something. You simplify it, right? Okay. And then based on the available condition, you will get a final answer. Okay, good. So let's do a brief review. So 3 terms you need to know. Parabola, vertex, axis of symmetry. So we call this is y-axis of symmetry. Horizontal one is x-axis of symmetry, right? So this is a formula you need to memorize. So this is for the situation y equals a, x always come with h, and then minus in between. Then you will get vertex h and k. Another format is this. If you write it as x equals a times y and k always come together. This h considered here is with x, okay? And vertex still keep same h and k. All right. All right. So h and k will now change. All right. Keep in mind. H go with x, k go with y. That's the now you will know. You will clear always. Y and k comes together. X and h comes together. Okay. All right. So homework. We have day 1 homework, a couple of problems, day 2, day 3. And oh, here is supposed to be day 4. AOPS, okay. Just trying to do the graphing quadratic, and don't forget the daily survey form. All right. I hope I can see more submission or response for this homework survey form. Please do your homework. Okay. The things here, I already sent a message to all your parents that for each student you need to prepare a notebook. For daily work, you need to have a date and then problem number on it. And then you have to show your calculation steps. Okay, so the steps. Okay, I'm not asking you to write down too many steps, but for some steps, if you can do mental math, just feel free to skip the steps. But please do not skip all the steps. Otherwise, if you do everything based on mental math first, I don't believe that you can do that. Second, you are going to make mistake. Okay. Do the homework, prepare a notebook, write down the date and the problem number. Later on, I may ask you, your parents, to check, or maybe send me a photo, all right? Okay. Please do that. Okay, I will, and then don't forget to submit the daily homework survey form. All right, any question? Thank you very much. Okay, everybody, good night. I hope to see you next time. All right, bye-bye.
Thank you.
Bye.
Thank you. Bye.
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 Bye-bye.